Hello 108 students, Mr. McCue here, getting ready to start section 1.4. I'm going to wrap up chapter 1 here on this page and the next page, and we are going to focus on properties of the properties of numbers. And the first one we're going to work on is the distributive property. Sorry there. Okay, so obviously we're going to go ahead and take on the first page here, so let's go ahead and get started. This first property, we call this the distribute because most of you are probably pretty comfortable remembering that you see the outside number or the side of parentheses. PEMDAS tells you to deal with the parentheses, and then you look at this and you go 3a plus 4b. They are not like terms. You cannot add them up. Think of this as like 3 apples and 4 bananas being packaged. This is the way how I like to think of the distributive property. So here you go to Fast Freddy Myers. There's a new one on Chinden and Linder. It's going to be built here for this summer. And you walk in, and I like to get fruit for every day. I'll try to eat a couple pieces of it. And I see this new packaging, and they've got 3 red apples in there and 4 bananas. And I'm like, okay, I'll pick one of those up. Then I decide to pick up 2 of them because my wife likes to eat fruit too. So we decide to go in. It's a good deal. So we buy those, and what happens is you've got multiplication going on outside the parentheses in the number, and that's assumed. You need to know that's multiplication. That's a key thing on your secret decoder ring. I usually raise up my hand in class and I show my engagement ring that's got some symbols on it, and it's a Claudia ring. And what I want you to think about is you need to have a math decoder ring. So what does your math decoder ring tell you? Whenever you see a number next to a set of parentheses, it means multiplication. So a lot of you are comfortable with this. You know the distributive property means they take the 2 multiplied by the first term, so 2 times 3a is what we're trying to show here, and then 2 times 4b is what we're trying to show with these little arching lobe symbols, arching lobes going down here. And so 2 times 3a, you multiply the coefficients and you get 6a, and 2 times 4b is 8b, and so you're left with 6 apples and 8 bananas. Okay, now what I got here on the side here is back to my example of going to Fast Freddy Myers. So imagine this visualization here that your first package has got 3 apples. Imagine these are bananas. There's 4 of them. I turn around and I buy another package for my wife. Like I said, there's 3 apples, 4 bananas. I pick them both up and I bring them home. And when I bring them home, guess what? I have to unwrap them. So distributive property is unwrapping the parentheses. You want to make the parentheses go away. PEMDAS tells you to deal with them first. You know multiplication's going on there. Okay, so when I unwrap them, I have 2 bins in my refrigerator. I cannot commingle fruit at our house. And so when I take the wrappers off, how many apples do I have? 1, 2, 3, 4, 5, 6 apples. There's my 6 apples. How many bananas do I have? 1, 2, 3, 4, 5, 6, 7, 8. And that's just a quick visual way to help you remember the distributive property. Many students are probably very comfortable just knowing what's going on with the parentheses and the assumed multiplication and multiplying. 2 times 3a is 6a, 2 times 4b is 8b. So many students will go straight from this step and you'll come down right to here. And you probably should. But make sure you understand the concept so you can use it over and over again. That leads us into what I call the reverse distributive property. And we're going to do this when we get into chapters 5 and 6 here down the road. You did this in 025. It's called factoring. Now, I don't want to jump the gun here and go crazy with it, but it's going in a reverse direction of the distributive property. So here's the answer, 6a plus 8b. And if I asked you to repackage it or find out a set of parentheses got the same elements inside them, how many sets could I find? And so the way we usually do this in math classes, we say pull out the greatest common factor. That's what GCF is, greatest common factor. So look at 6a and 8b. What's common in both of them? The coefficients 6 and 8, but what's the biggest number you can take out of them evenly? 2. Why? Because 2 times 3 is 6, 2 times 4 is 8. 2 times 3 is 6 is 6a, and 2 times 4b is 8b. So this is called factoring. The big thing that you're doing is you have the addition of 2 unlike terms. A and B are different terms. You cannot add them together. They cannot be combined, but can you package them? And the answer is yes. You can take out the greatest common factor of 2, and you're left with the package of 3a plus 4b. Okay, and factors, why they call them factors one last time, the assumed multiplication going on between them. Okay, now a couple examples real quick here. What do you think you do if you see -2 parentheses 5 plus k parentheses PEMDAS highest order of operation to deal with? You know the assumed multiplication is going on there, so 2 times 5 is -10. -2 times a k is -2k. And here's your answer. Okay, now what's interesting, I look at this example real quick, and they want you to realize R and R, and this is just a case of saying what's the greatest common factor between these two terms. The R is in both of them, so you can pull out that variable. That's the greatest common factor. And what are you left with? 3 times what gives you 3R, so 3 times 3 produces 3R. And finally, R times 7 would produce -7R. Okay, now that's just to get this reverse distributive property process going. A lot of you might look at this and say, wait a second, aren't 3R and 7R like terms? And that's a very true statement, because when you have the same base and the same exponent, which assumes to be 1, you can combine like terms. And when you hear the word combine, I'm going to say it over and over again. CLT, combine like terms, means 3 minus 7 equals -4, and you keep a like term. Okay, so you'll see my teaching style here. You got to get used to acronyms. I'm a systems engineer, and I'm used to working with them, and it's just a convenient way to take common terminology and reduce it down to some acronyms. So if you say CLT, think of combined like terms, but don't think of it like BLT, which is bacon, lettuce, and tomato, and it makes me hungry thinking about it. So, okay, so there's a little my humor that I usually try to do in class. Hopefully you don't think it's too corny. Now let's look at objective number 2 here real fast. And the inverse properties, they undo. And additive inverse, what can you add to a number to give you that produces 0? Now these properties, we use these over and over again in isolating the variable. So ask yourself 3 plus what equals 0? And ask yourself this idea. If I got $3 in my wallet and I go to Sonic and I buy a $3 limeberry cream slush, I owe the cashier $3, and when I pay it, what am I left in my wallet? 0. So the additive inverse of 3 is the opposite, -3. And it would go the same way. If I had -3 and I said add it to what will produce a 0, you would put a +3. So it's always the opposite sign. See the -3 and a +3? Okay. Now, B here says multiplicative inverse, says take a number like 3, multiply by what produces a 1. And hopefully you remember what a reciprocal is. If you take the number 3 divided by 1 is a way to represent a whole number as a fraction. The reciprocal is to, you can't see my hands, I'm flipping the numerator denominator, so the 3 goes down, the numerator goes down, the denominator goes up, so the reciprocal is 1/3. 3 times 1/3 does equal 1. You could put that like that if you needed that. Remember, 3 over 3 cancel out. 1, because we say cancel, what's 3? Sorry about that. We say cancel. 3 divided by 3, anything divided by itself always equals 1. We'll use that 1,000 times today, or in this semester. Okay, one last thing. Objective 3 says identity properties for addition. 3 plus 0 will always produce itself. 3 plus 0 is itself. How about when you want to do multiplication? 3 times what equals itself? The answer is 1. So the additive identity property for addition is 0. The multiplicative identity property is 1. And we do this all the time. If we say, we finally come down and work an algebra problem, we say 1x equals 5. We're using this identity property. 1 times anything, class, is itself. 1 times x is x. And therefore you finally isolated that variable. And you know what it is. Okay, hey, that's going to wrap up page 1. We're finishing up 1.4 page 1. We will move on to 1.4 page 2, and that's going to get ready to wrap up this chapter. Okay, I'll see you in a little bit.